Hello, and today we will discuss about signals and demo process, in which we are discussing about signals, the unique kernels of the signals, signal mask, sig action, then child signal, wait PID function, set jump, signal set jump and signal long jump functions, kill and alarm APIs, interval timers and POSIX timers, daemon process, its characteristics and coding rules, error logging facility, then finally client server model. First, we need to understand what we mean by signals. Signals are triggered by an events and are posted on a process to notify something has happened and require some actions. So you might be heard the word signals. One of the best example we can consider here, traffic signals. So whenever we know that there is a three indicators there, if suppose the red signal appear, that is the red light, then we need to stop. If the orange appear, then we're ready to go. If green appear, then move from that side. So this is what the event is happening. According to that, we are performing the action. The same thing is applicable as part of the Unix operating system. The processes are communicating with each other through some signals. Means they are performing the one event. Yes. So based on that, the corresponding process will take some action. These signals can be generated from a process or a user or a Unix kernels. I mean, the source of the signals are from a process, a user, or Unix kernel. Maybe you are getting the question how a process. So a one process, say for example A and B are the two processes. Here the process A can send the signal to process B. This is the one way of generating the signal. Then user. Whenever user is pressing some keys on the keyboard like Control C, due to that one signal is generated. Or if I press the delete key, then it is a one signal is generated. Next, Unix kernel. I mean, as we know that it is a part of the Unix operating system. So due to that also there is many signals are generated here. He's taken some of the examples. A process performs a divide by zero or defines a null pointer. I think it is a mathematical operation. We know that whenever the divide by zero is performed, then we get the infinity. Next, if I press the delete or Control C, then at that time also some signals are generated. Next, a parent and child process can send signals to each other for process synchronization. We know better what do you mean by process synchronization. Whenever the resource utilization is required at that time, this concept has been used, that is a process synchronization. So the processes are communicating with each other for uses of the resources. Thus, the signals are software version of the hardware interrupts. Maybe you are getting confusion here. Signals are software versions of the hardware interrupts. Anyway, it is internally software, but it is generated due to hardware interrupts sometimes. Then all the signals are defined as part of the one of the header file named as signal.h. As we know that in C language, we are using one of the standard file like stdio.h, just like that, signal.h. And every signal has a unique number, that is what we can call as a signal number. And every signal is also identified by its name, like it's begin with the SIG, SIG, the three characters. Whenever the signal is sent to a process, it is pending on the process to handle it. At that moment, the process is not responding here. Some of the signals have been listed here. The one of the familiar signal, alarm signal. Description is timer is expired. So I hope you might be using the alarm and moving the hours to wake up. If I kept the alarm at 6 a.m., then at that time the time expired, then there is a one beep sound is generated. That means there is some event is happen. So according to that, the particular person is taking the action. Either he need to stop that alarm and wake up. And what is the default action with respect to this signal is terminate. Terminate means the process is terminated. It stop execution. Next, we have a wait signal. Usually, this signal has been used for a normal termination of the process. Okay. When we have floating point error, whenever we are performing the wrong arithmetic or expressions or with mathematical expression related, it is happening. But default action is terminate and core file is generated. Next one is hang up signal, then illegal signal, then interrupt signal, next kill signal, pipe signal. So here pipe signal is nothing but, I think we use that concept already. Whenever the writer process is ready to write the data, but there is no reader process, in that case the signal is generated. So some of the just like that we have signals. When a signal is sent to process, it is depending on the process to handle it. The process can react to pending signals in the three ways. That means, whenever a particular signal is received by a receiver process, it can react in different ways. One is accepting the default action, second one ignoring the signal, and third one is user-defined function. Here the default action is nothing but the process will terminate itself. Ignoring the signal is nothing but just discarding it, and it could not have any impact on the recipient process. Then user-defined function is nothing but just like this, what I can call as a signal handler. Okay. So the signal has been caught. Okay. So most of the signals can be caught or ignored except sig kill and sig stop. The maximum signals has been caught or ignored, but except kill signal and stop. Then to remove signals here, stop signal and continue signal, they are performing opposite operations here. One is stopping the execution of the process, but one more signal is it resumes the stop the process here. Okay. Next, a process is allowed to ignore the certain signals so that it is not interrupted while doing the certain mission critical work. I mean, in which circumstances we can ignore the signals. The one example has been considered here. A DBMS process updating the database file should not be interrupted until it is finished. Else, database will be corrupted. It should restore signal handling actions for signals when finished mission critical work. So that means, whenever one example I will try today. Assume that banking database and the backend there is one process is performing the updating the transactions of the all customers on that day. So during that time, if I send any signal to that process, in that case the process just ignore the signal because it is doing the one critical work. Okay, otherwise what happens? If it is reacting to the signal, then the database will be crashed. Usually the signals are generated asynchronously to a process. The signal may specify the handler function per signal basis. Means if suppose signal 1 is, the interrupt signal concerned, we have some mechanism. For kill signal we have mechanism. For stop signal we have mechanism. That way per signal basis we can define the handler function. The common practice of handler function is to clean up a process work environment such as closing all input and output files before submitting. Next, Unix kernel support for signals. I think already similar concept has been discussed with respect to the process. Each entry in the kernel process table slot has an array of signal flags. So we know that flag means they are 0 or 1 indication here. One for each defined in the system means for every signal we have one flag value. When signal is generated for a process, the kernel will set the corresponding signal flag in the process table slot of the recipient process. That means. So whenever the signal is assume that the input signal is generated, at that time that value is set to 1, otherwise its value is remains 0. If the receiving process is asleep, the process is currently in asleep, waiting process, in that case it is wake up that process and screen it. And the reference process runs, the kernel will check the process U area that contains an array of signal handling specifications, where each entry of the array corresponds to signal defined system. Means how to handle a particular signals. Means whether we need to take the default action, whether we need to take the ignoring the signal, or we need to consider as a user default function. The kernel will consult the array to find out how the process will react to the pending signal. If the array entry contains a 0 value, in that case the process will accept the default action of the signal and kernel will if the array value contains one value, then the process will ignore the signal. Means we are just ignoring the signal, it could not have any effect on the recipient process. Finally, if the array entry contains any other value, it is used as the function pointer for user defined function. That means signal handler, the concept of the signal handler has been used. Any other value means the process slot is containing the 0, 1 value. 0 means default action, 1 means ignore, and other than 0 and 1 can have the user defined function. The kernel will set up the process to execute the function immediately, and process will return to its correct part of execution if the signal handler does not terminate the process. If there are different signals pending on a process, then the order in which they are sent to the receiving process is undifferent. Hence, whenever we are reacting to the signal, the process is reacting to the signals. It is not dependent on the order in which they are received, rather than there is a priority basis. If the multiple instances of the signals are pending on a process, it is dependent on whether a single instance or multiple instances of the signal will be delivered to the process. Means, usually what happens, the same signal is repeatedly arriving in the recipient process. So it is multiple instances what can say that will be delivered to the process. Then in that case also it is delivered even though it is pending signals. So each signal flag in the process table slot records only whether signal is pending but not how many of them are present. So we are recording about only whether the signal is pending, not how many signals are pending. So one of the API we are using for handling the signal is Signal API. This Signal API is not returning any value here. Just we can it contains the two arguments. One is the name of the signal and second one is the handling method. And this we can find it one point as a written signal number is signal identifier like input signal or terminal signal. Handler is a function pointer or user defined signal handle function. This function taken as an integer formal argument and does not return any value here. Means that is the handler is also not returning any values. So always we are taking the integer value as well the 0 for default action, 1 for ignoring the signal, other than 0 and 1 it is user defined function. So here in the program just I call the signal API 3 times. One is terminal signal, we call the user defined function. Next for interrupt signal we are ignoring the signal. For segmentation fault signal we are calling the default function. This pause is nothing but wait for signal interruption to be occurred. So just we can find for catch signal the user defined function is here. Okay. So this user defined function has been called that indicate that the signal has been catched with respect to the particular signal number. So one more thing we have to understand here. The return value of the signal API is the previous signal handler for the signal. That means the return value of the signal API usually, say for example, the previous handling method is the default action, so that one value will be written here. Okay, we'll continue in the